Hi, welcome to TechMark channel. Today, I intro for you demo Cloud Firebase of Google with Friendly Eats sample project. 1. Overview goals. In this Codelab, you will build a Firestore-backed restaurant recommendation app on iOS and Swift. You will learn how to read and write data to Firestore from an iOS app. Listen to changes in Firestore data in real time. Use Firebase authentication and security rules to secure Firestore data. Write complex Firestore queries prerequisites before starting this Codelab. Make sure you have installed Xcode version 8.3 or higher, CocoaPods 1.2.1 or higher. 2. Get the sample project. Download the code. Begin by cloning the sample project and running pod install in the project directory. Git clone, https://github.com/firebase/friendlyeats-ios cd friendlyeats iOS pod install. Open fireeats.xcworkspace in Xcode and run it, cmd+r. The app should compile correctly and immediately crash on launch, since it's missing a Google service-info.plist file. We'll correct that in the next step. The documentation to create a new Firestore project. Once you've got your project, download your project's Google service-info.plist file from Firebase console and drag it to the root of the Xcode project. Run the project again to make sure the app configures correctly and no longer crashes on launch. After logging in, you should see a blank screen like the example below. If you're unable to log in, make sure you've enabled the email password sign-in method in Firebase console under authentication. 3. Write diction will write some data and populate the app UI manually via the Firebase. We'll do it in the app itself. Firestore write. The app is a restaurant, split into documents, collections. We will document in the top level class. If you'd like your data model, runs in the documentation data to Firestore, we the restaurants collection. Enter for loop in the restaurant did tap populate button collection equals Firestore restaurants collection reference. We can add the following just as we added. Document to the restaurant's document data comes from a restaurant struct. Firestore uses dictionaries and but it's best practicing data to use a value t then dictionary. Swift for the implement types. We're almost in write documents to Firestore's security rule. Parts of our database should be for now, cated users to read and write. This is a little too prep, but during the app building relaxed enough so we authentication issues while at the end of this Codelab harden your security rules of unintended reads in the Firebase console and enter then rules in the Firestore alt rules prevent any reads from any user. Following rules we'll in detail later, but take a look at the security rule. Run the app and sign populate button in the update a batch of restaurant doc. Yet see this in the app date to the Firestore data tassel. You should now collection, congrats just written data to Firestore. In the next section data from Firestore and display. You will learn how to retrieve data from Firestore and display it in the app. The two key steps are creating a query and adding a snapshot listener. This listener will be notified of all existing data that matches the query and receive updates in real time. First, let's construct the query that will serve the default, unfiltered list of restaurants. Take a look at the implementation of restaurants table view controller.base query. Return Firestore.collection, restaurants.limit to 50. This query retrieves up to 50 restaurants of the top-level collection named restaurants. Now that we have a query, we need to attach a snapshot listener to load data from Firestore into our app. Add the following code to the restaurants table view controller.observe query method just after the call to stop observing. The code above downloads collection from Firestore and stores it in an array locally. The add snapshot listener call adds a snapshot listener to the query that will update the view controller every time the data changes on the server. We get updates automatically and don't have to manually push changes. Remember, this snapshot listener can be invoked at any time as the result of a server-side change, so it's important that our app can handle changes. Note: it is also possible to fetch documents from Firestore once, rather than listening for real-time updates, using the query.getDocuments completion method. After mapping our dictionaries to structs, see restaurant.swift. Displaying the data is just a matter of assigning a few view properties. Add the following lines to restaurant table view cell.populate restaurant in restaurant table view controller.swift. This populate method is called from the table view data sources table view _ cell for row and index path method, which takes care of mapping the collection of value types from before to the individual table view cells. Run the app again and verify that the restaurants we saw earlier in console are now visible on the simulator or device. If you completed this section successfully, your app is now reading and writing data with Cloud Firestore. 5. Sorting and filtering data. Currently our app displays a list of restaurants, but there is no way for the user to filter based on their needs. In this section you will use Firestore's advanced querying to enable filtering. Here's an example of a simple query to fetch all dim sum restaurants. Let filter query equals query.wherefield category is equal to dim sum. As its name implies, the wherefield _ is equal to method will make our query download only members of the collection whose fields meet the restrictions we set. In this case, it'll only download restaurants where category is dim sum. In this app the user can chain multiple filters to create specific queries, like pizza in San Francisco or seafood in Los Angeles ordered by popularity. Open Restaurants Table View Controller.swift and add the following code block to the middle of query. With category city price sort by . The snippet above adds multiple wherefield and order clauses to build a single compound query based on user input. Now our query will only return restaurants that match the user's requirements. Run your project and verify you can filter by price, city, and category. Make sure to type the category and city names exactly. While testing you may see errors in your logs that look like this. This is because Firestore requires indexes for most compound queries. Requiring indexes on queries keeps Firestore fast at scale. Opening the link from the error message will automatically open the index creation UI in the Firebase console with the correct parameters filled in. To learn more about indexes in Firestore 6, visit the documentation. Writing data in the transaction. In this section, we'll add the ability for users to submit reviews to restaurants. Thus far, all of our writes have been atomic and relatively simple. If any of them errored, we'd likely just prompt the user to retry them or retry them automatically. In order to add a rating to a restaurant, we need to coordinate multiple reads and writes. First, the review itself has to be submitted, and then the restaurant's rating count and average rating need to be updated. If one of these fails but not the other, we're left in an inconsistent state where the data in one part of our database doesn't match the data in another. Fortunately, Firestore provides transaction functionality that lets us perform multiple reads and writes in a single atomic operation, ensuring that our data remains consistent. Note: transactions are appropriate for complex write operations that also require intermediate reads. If you're just looking to write a bunch of documents at once and don't need to worry about intermediate reads or operation order, you should use FIR batch instead. Add the following code below all the let declarations in restaurant detail view controller.review controller _ did submit form with review. Inside of the update block, all the operations we make using the transaction object will be treated as a single atomic update by Firestore. If the update fails on the server, Firestore will automatically retry it a few times. This means that our error condition is most likely a single error occurring repeatedly. For example, if the device is completely offline or the user isn't authorized to write to the path they're trying to write to. Note: when a transaction fails on the server, the update block is also re-executed on each retry. Avoid placing logic that modifies app state inside the update block. 7. Security rules. Users of our app should not be able to read and write every piece of data in our database. For example, everyone should be able to see a restaurant's ratings, but only an authenticated user should be allowed to post a rating. It's not sufficient to write good code on the client. We need to specify our data security model on the backend to be completely secure. In this section, we'll learn how to use Firebase security rules to protect our data. First, let's take a deeper look at the security rules we wrote at the start of the Codelab. Open the Firebase console and navigate to Database Greater Than Rules in the Firestore tab. The request variable in the rules above is global variable available in all rules, and the conditional we added just ensures that the request is authenticated before allowing it to do anything. This prevents unauthenticated users from using the Firestore API to make unauthorized changes to your data. This is a good start, but we can use Firestore rules to do much more powerful things. Let's restrict review rights so that the review's user ID must match the ID of the authenticated user. This ensures that users can't impersonate each other and leave fraudulent reviews. Replace your security rules with the following. The first match statement matches the sub-collection named ratings of any document belonging to the restaurant's collection. The allow write conditional then prevents any review from being submitted if the review's user ID doesn't match that of the user. The second match statement allows any authenticated user to read and write restaurants to the database. This works really well for our reviews, as we've used security rules to explicitly state the implicit guarantee we wrote into our app earlier, that users can only write their own reviews. If we were to add an edit or delete function for reviews, this exact same set of rules would also prevent users from modifying or deleting other users' reviews as well. But Firestore rules can also be used in a more granular fashion to limit rights on individual fields within documents rather than the whole documents themselves. We can use this to allow users to update only the ratings, average rating, and the number of ratings for a restaurant, removing the possibility of a malicious user altering a restaurant name or location. Here we split up our write permission into create and update so we can be more specific about which operations should be permitted. Any user can write restaurants to the database, preserving the functionality of the populate button we made at the start of the Codelab. But once a restaurant has written, its name, location, price, and category cannot be changed. More specifically, the last rule requires any restaurant update operation to maintain the same name, city, price, and category of the already existing fields in the database. To learn more about what you can do with security rules, take a look at the documentation in this Codelab. You learned how to basic and advanced reads and writes with Firestore, as well as how to secure data access with security rules. You can find the full solution on the Codelab Complete branch. To learn more about Firestore, visit the following resources. Introduction to Cloud Firestore. Choosing a data structure. Firestore iOS samples.